Which then ties into graphing.
Yes. Okay. So we're on the fourth of the 5. We've done, again, square roots, factoring, completing the square, and then today we're going to do the quadratic formula, okay? So to reiterate, what we've been working with is this quadratic equation, which has been in the format of ax squared plus bx plus c equals 0, okay? And we're going to really be working with the a, b, c values today, okay? You may recall that there's the quadratic formula, which is using the values of a, b, and c and plugging it into a formula, and then you actually get your answers, okay? So the formula is x equals negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a, okay? So that should probably bring back some really good math. Awesome. Okay, so what we're going to just kind of focus on right now is this word called the discriminant. And if you notice here, this b squared plus 4ac, which is underneath the square root sign, okay, that is what we call the discriminant. And the discriminant, again, it's just what's underneath the square root. It's not the square root of it, it's just what's underneath it. That actually tells us things about what we're going to expect, okay? So we're going to solve for the discriminant in all these, and then we'll show you how that actually helps you with the equation, okay? So if I'm going to look at the discriminant, again, the discriminant is going to be b squared minus 4ac. All right, so we're going to look at these 4 equations. So 3x plus 3x squared plus 2x minus 8. What is the a value in this one? It is 3. What is the b value? 2. And what is the c value? Okay, so you're going to have to, number one, make sure you've always put it in standard form. If you don't put it in standard form, you guys, and you just pick whatever order it's in, a, b, and c, then you're going to get the wrong answer. So make sure you have it where the x squared is first, the x, and then the c. If you do not have a b value or you do not have a c value, they're still there. They're just what?
1.
No. 0. Okay? So if this was like 3x squared plus or minus 8, b would actually be 0. So just because it's not there does not mean it's not a value. It just is 0. Okay? Alright, so let's go ahead and put in this discriminant equation part. So it's going to be 2 squared, okay, minus 4. Your a is 3, and your c is negative 8. Okay? So all I did was put the values in. And so when I solve this, I'll get 4 plus 96. And that equals 100. Okay? Good? Alright, we're going to move on to the next one. So, negative 3x squared plus 5x plus 5. Is it in standard form?
Yeah.
Excellent. So therefore, a is what? Negative 3. B is 5. And c is 5. Okay? So plugging it into this equation, I'm going to have 5 squared minus 4 times negative 3 times 5. And that will equal 25 plus 60, which then equals what? 85. Okay? And then these numbers will all mean something to us in just a minute. Alright, so now we're going to look at the third one.
I have a question.
Yes?
When would you use this?
Yeah, so you guys, when you have, like this is a, like I said, all these solutions, you guys, give you the same answer. Square root, factoring, completing the square, and quadratic. They all will give you the exact same values, right? One is going to be easier to use than the other.
Yeah.
When you have something in front of you that you cannot factor, like it looks possible, then you're going to use the quadratic because it's just plug and play, right? You don't have to worry about separating them. When you have something that looks really easy that you can factor it. You can choose any of them and you should get the exact same answer regardless. Okay? So you can pick what you want to do unless you're being asked to do it a certain way.
Yeah, that's what I was gonna say.
Yeah, I think on the test, there's at least one problem of each where it says solve it this way, and it tells you which way to solve it, and then there's like 2 or 3 more that says do whichever way you want. Okay? But you could always, to give you a hint, if you like this way and it works for you, you can use it to help you do the other way. Like let's say you're not good at factoring. If you do the quadratic, you'd kind of get at the answers and you could work your way backwards in how to factor it. No, you can't go from factoring to quadratic because you actually have to plug and play. You have to actually fill those in.
You do factoring to figure out the answers and then do it the right way.
It wouldn't, because you'd have to fill this all. You could check it that way. You could check it. Okay. So what is A on this example? 1. What is B? -4. And what is C? Okay. So this one will be B squared, which would be -4 squared, minus 4 times 1 times 4. So then I'm going to get 16 minus 16, which equals what? 0. Okay? So let's look at this last example. What is A? What is B? And what is C? Any guesses what your answer might be on this one, just by looking at the pattern? What did you say? Negative? Let's see. Alright, so we have B squared, which would be 1 squared, minus 4 times 2 times 1. So I got 1 minus 8, which is -7. Yay! -7. Okay, so there are 4 different examples here. Do you have a question?
Yeah.
Yeah.
So when you said that when the would be 0, I mean,
Okay, so what all we're doing right now, you guys, is I'm showing you how the quadratic, you can use the discriminant, which is this part right here of it, and it can tell you what you're going to, the answers you're going to get, the type of solutions you're going to get. Okay? And that's what we're going to do from this point forward. You'll see how they kind of, the relationship of these numbers to what you're going to actually see. Okay? Question?
So my only thing was like, so how you said if there's like nothing there, then you plug in there, but that's only for C because getting B to live and actually plug in 1.
Well, it's like, when I say that, let me give you the example here. Let's say I give you this. And I say use the quadratic. Okay? So what is my A value on here? It is 3. What is my B value?
0.
It is 0. I don't have a BX, right? There's no X value, so it's 0. Okay? And then my C would be 0. Okay?
So what if it's,
I mean 10, sorry.
so what if it's vice versa, like it's 3x squared plus 1x and then nothing?
Okay.
Still be 0.
Yeah, so then A is 3, B is 1, and C is
so
0.
it only matters whether it's actually, like,
Yes, if you do not see the value, and you'll never have it where the x squared's not there, because then you're not solving a quadratic then. So the x squared has to be there. If it's not there, it's not a quadratic, right? So at this point, so then you could put them in. So this one would be like, if I would do the quadratic on this, it would be negative b, which is -0, plus or minus the square root of 0 squared, minus 4 times 3 times 10, right? And that's all over 2 times 3. So you still can plug in your values, right? So it's just going to be 0 plus or minus the square root of 120, a -120, all over 6. Okay? Yes? Yes. Okay. Questions on, did I answer your question then, you guys, on this? Okay. Alright. So now, why am I telling you this? Because based on the answer that you guys get within the discriminant, it's going to tell you what type of answers you're going to get. So 100. This is going to fall underneath the square root sign. So what is the square root of 100? It is 10. It is what we call a perfect square. I'm going to say a perfect positive square. Okay? So if I get a perfect positive square, okay, I'm going to have what we call 2 real answers, and they'll be rational. meaning that they're like 2.5 or 3.78, like they end, right? So you'll have two real rational numbers, answers. And what that will mean, we're not going to graph it in this unit, but what you're actually realizing is that it's going to cross the x-intercept twice. Okay? So you'll actually hit the x-axis twice. So you'll have two x-intercepts. Actually, I spelled it wrong. There you go. Okay?
So we aren't doing that part though.
You won't be doing this, but I'm just showing you what you're actually solving for. Okay?
We won't be doing.
We won't be doing the graphing in this unit. We'll do it next unit. Okay? So, 85, square root of 85. Is it a perfect root? Is 85 a perfect square? No. So at this point, we have what's called a positive non-perfect square. Okay? So we have a positive non-perfect square, meaning it's like the square root of 17, the square root of 85. It's not going to be a perfect square, okay? And at this point, you have two real irrational numbers that you're going to get. So an example would be like, again, square root of 17 might be like 2.7891234895, and it goes on and on, right? But the graph is the same as well, where it will intercept the x-axis twice. Those are your two answers. Remember, we're trying to find the roots or the zeros, right? You're trying to find where it crosses the x-intercept. So that is a situation where you actually have two x-intercepts as well. Okay? When I have 0, you get one real, rational number, and we call this the double root. So like it's almost like you're going to have like x plus 8 squared. So this is this PST situation. Okay? And what that means is there's only one answer of x, right? So like if I have x plus 8, x equals negative 8 twice, right? So that really is saying, oh, it's over here, and I only hit the axis once. So I'll have one x-intercept. Okay, and we call that the vertex. Okay? So when you get this situation, there's only one value that's at the x-axis. There's only one 0, there's only one root. So when it's negative, it's what we call the complex. And there's two imaginary numbers. And what the graph looks like on that one, it's never going to touch the x-intercept. It's never going to touch the x-axis. It never ever reaches. So there's no x-intercept. Okay, and you don't need to graph them in this unit, okay? But you need to understand that those, like you have two roots, here you have one, and here you have none, okay? And this is what the discriminant tells you. That's what it's telling you, okay? All right? Right here, the discriminant I just kind of mentioned, I'm just going to, if you have two rational roots, it's a positive perfect square. Okay? If the discriminant has two irrational roots, then it's a positive non-perfect square. Okay, if it has one rational root, what do we know about the discriminant? There's one rational root. What's the discriminant going to be? What's the value going to be? It's going to be 0. Okay? And if we have the discriminant that has two imaginary roots, we know that it's going to be negative. Okay? So we can use the roots to determine what the discriminant is. We use the discriminant to tell you what type of roots it is. Okay? Does that make sense? Alright, so using that information, we're going to go and actually, does everyone have that?
No.
Okay, I'll leave it for a sec. So, here we have a couple situations here, all right, in regards to solving these. Now, when you're using the quadratic formula, you don't need to do anything except for no A, B, and C. Put in standard form, no A, B, and Z. So the hardest thing that you guys are going to probably find on the test is just struggling with what thing am I solving, because like if I would look at this as completing the square, what would I do? Let's say I said complete the square. You would throw that over, you would divide by 2, right? You would start doing something else. So you have to be able to compartmentalize what way am I solving it and the steps that go with that one way. The quadratic formula is super nice because all you got to do is know A, B, and C and plug it in. Okay, does that make sense? Okay, so I'll write it up here just so we can remember it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So I personally always write out A, B, and C because then I see it right away and I don't get lost. And I can just focus on the numbers. Okay? So A is 2, B is 1, C is negative 5, or 15. Okay? So I'm now just going to plug it into the equation. So I'm going to do negative 1 plus or minus the square root of 1 squared minus 4 times 2 times negative 15. Now, if you guys are plugging this into your calculator, you need to be very careful about using parentheses around those negatives, because your calculator is not going to read it the way unless you have parentheses around those negatives. Okay? Well, it means if I plug into my computer and just said 1 squared minus 4 times 2 times negative 15,
You need to create a bigger parenthesis.
you just need to put the parentheses around each one just to make sure it's reading the parentheses the right way, because it might read as minus 15 is what it's going to read as.
You also put like a parenthesis there and you calculate a parenthesis there, and then it would do that first before.
No, because it's going to take 2 minus 15 first then.
Oh.
Okay? Alright, so now I'm just going to do the math, you guys. It's minus 1 plus or minus, sorry, 2, I don't know where I got the 3. 2 times 2. 2 times 2. Okay? So then, I'm going to do the math here. I'm going to get 1 squared is 1. Okay, so negative 4 times 2 is 8. And then 8 times a negative 8 times a negative 15 becomes a negative 1, or a positive 120. Okay, so I have negative 8 times a negative 15, that's a positive 120. Okay? Put that all over 4. So that's minus 1 plus or minus the square root of, well, 1 plus 120 is 121. And that's all divided by 4. So just looking at what is the discriminant now? We can actually write with the discriminant. What is it? Well, no, the discriminant is what's inside the square root. What is it? 121. Alright, what situation does that fall into? Is 121 a perfect positive, perfect non-positive? Perfect positive. So therefore I know I'm going to have 2 real rational numbers, right? So I'm going to have 2 real rational numbers, okay? Alright, so now I can solve this. This is negative 1 plus or minus 11 all over 4. So this is going to be 10 over 4, or it's going to be negative 12 over 4, which is a negative 3.
How did you get from 10 to 12?
Okay, so I have, here, I'll do it 2 ways. I'll do it this way. Okay, so I have negative 1 plus 11 over 4, and I have negative 1 minus 11 over 4. Those are my 2 situations, right? So I have 1 plus 11, and I have 1 minus 11. So 1 plus 11 is 10 over 4, right? And then 1 minus 11 is negative 12.
Oh, and you can't
I cannot reduce, well, this one I can make it to 5 halves. That could be 5 halves.
Do you want us to do that?
Yeah, you should reduce it. And this will be negative 3 then. That's negative 3. This would be 5 halves. So 5 halves and negative 3.
So if we don't reduce it, we're gonna get knocked out.
You probably would lose like a half a point. Okay? 5 halves is 2.5, right? Okay, 2.5 is a rational number, isn't it? It ends, right? It's a number that ends, because that's what rational numbers are. They actually end, right? Negative 3 is a rational number, so there you go. You got your two real rational numbers. Make sense? Well, then you probably have a math error. Yeah, and that's what a discriminant is good for, because it will tell you if you did it correctly. Like, if you get a discriminant of 0, and you, like, solve for something other than what it should be, then... Okay, right. Yep. Okay, the next one. Here we go. So A equals 2 on number 2. B is negative 9. And C is 8. Right? A is 2. B is negative 9. C is 8. Alright, so I'm going to put in my formula. I'm going to have negative 9. Okay, yep. Plus or minus. So it's negative B. You could. Yeah. I just always show you how we get there. If I just put a positive 9, then you're going to be like, where did the negative 9 go? So I just do this and I'll bring it down.
Yeah, you're right.
Right? Okay, so plus or minus the square root of b squared, so negative 9 squared. This is where you want to make sure you have it in parentheses in your calculator, because otherwise it will square the 9 and add the negative later. Okay? Minus 4 times 2 times 8.
Mr. Wires down.
All over 2 times 2. Okay? So this becomes 9 plus or minus the square root of 9 squared, negative 9 squared is 81, minus, okay, so this is going to be 8 times 8, which is 64, and that's all over 4. Okay? So therefore, that's 9 plus or minus the square root of 17, all over 4. Okay? So you can leave it that way, because it's a square root of 17. You can convert the square root of 17 to decimals and actually solve for it. But those are your two answers. You have where it then is going to be 9 plus the square root of 17 over 4, and 9 minus the square root of 17 over 4. You can leave it like this, or you can separate it. Okay? But you can see then how this is like irrational, like square root of 17 goes on and on and on and on, right? Well, notice how it's a non-perfect square, right? So your discriminant is 17, which tells you have two real irrational numbers. Does that make sense?
You can't get any further.
No, that's, I mean, you can convert it to a decimal and actually find a decimal number, but this is fine. This is fine. Okay? Okay, 3. So I think I heard someone say, oh my gosh, why, right? Okay, so let me just throw this out there, you guys. When you see that you have a fraction in this, get rid of it, okay? So multiply it by the greatest common denominator that would get rid of it for you. So what's a number I can multiply all terms by to get rid of the 7? 7. So I'm just going to take this whole thing and multiply it by 7. Okay? When I do that, all my fractions cancel, don't they? And then because I multiplied all terms by 7, I'm good. So then these cancel, these cancel, these cancel. So I'm left with 5x cubed plus 4 equals 2x. Alright, what do I need to do next? Put it in standard form. It is not in standard form, put it in standard form. So that's going to be 5x cubed minus 2x plus 4. Right? So what is A?
5.
What is B?
-2.
What is C? Okay. Alright. So, are you guys all good with how I got rid of the fraction?
Yeah.
Okay. When you multiply everything by something, you can get rid of all the fractions, and then you're good. Then I brought the 2 over, put it in standard form, gave my A, B, and C. Right? At this point, I just put into my equation, and I have negative 2, plus or minus the square root of negative 2 squared, minus 4 times 5 times 4. Put it all over 2a, which is 2 times 5. Is everyone good with how I plugged it all in? Okay. So now I just multiply through. So I'm going to have 2 plus or minus the square root of 4 minus, well, 4 times 5 is 20 times 4, and that's going to make it 80. And that's all over 10. Okay?
I know this is an unimportant fact, but where did you get the 3 squared as far as 5x?
Oh, it's just 5x squared. I'm sorry. I don't know why I did that.
Just weird.
No, I appreciate that. Thanks for noticing.
Hold on.
Alright, so at this point, you guys, when I do the inside of the, I got 2 plus or minus the square root of, what's 4 minus 80? Negative 76, and that's all over 10. So now what do I know? My discriminant is what? It's negative 76. It's negative, so what do I know about the answers?
It's
Two imaginary. Two imaginary, okay? So now that I know it's 2 imaginary, what do I know I need to do with this negative right here? Pull it out, right? Make it an I. So I would write this as 2 plus or minus I square root of 76 over 10.
Susan, can we just leave it there?
Okay? So you guys good with what I do with that negative then? When you have an e, when you have the negative square root, you need to bring the I out. Okay? Does that make sense?
Yeah, just leave it.
Okay. The answer becomes, can we just leave it that way? And the answer is technically you could, but you should reduce the fraction even more, or the radical even more. You don't have to, but I'll tell you what the answer is if you did it. It would be 2 plus or minus 2i square root of 19 all over 10.
But to be clear, you do not have to do this.
Well, in a test you'll have to do it. Yeah. Well, here's the thing. If you're doing a multiple choice and you have this answer, and the answer is actually not even going to be this because I can reduce the 2's, you have to realize how you got to that point. So, okay. All right, let's just real quickly move on to the next one. All right, so you guys see how you have 2 imaginary numbers then, right? You have 2 plus or minus a 2i. That's 2 imaginary numbers. Good?
Good.
All right.
How to reduce either way?
Well, yeah. Yeah. The final answer, you guys, is going to be 1 plus or minus I squared root of 19 over 5. Because I can reduce 2 out of both, and that reduces that. Okay? Alright. It's over 5 because the 2 comes out, and I can reduce 2, 2, and 5. Right? Okay. Alright, so on this one, it's in standard form, is it? Is it in standard form? Is it in standard form? No, put it in standard form. You're going to have x squared minus 8x plus 16.
Could be
You
easier if
could.
just kept the x squared positive.
You could do it, but then it will work out exactly the same. I like my x squareds to be positive.
Yeah, that's fine.
So, A is 1, B is negative 8, and C is 16. If you brought the x squared to the other side, then all these signs are different, and you get the exact same answer regardless. So it doesn't matter which way you do it. You'll get the same answer. Okay? All right. So negative B, so be negative 8, plus or minus the square root of negative 8 squared minus 4 times 1 times C. Okay, at this point it's all over 2a, so 2, 1. So I have negative 8 times negative 8, which is 8 plus or minus the square root of 64 minus 64 all over 2. I got 8 plus or minus the square root of 0 all over 2, so therefore I only have one answer, don't I? I got 8 over 2, which is 4. My discriminant is what? 0, which tells me I'll have one real rational number. And that's true, because notice how I just have one. Okay? So when you get that, you should be able to see that you get your answer. And the reason why you do is because the plus or minus cancel out and you just have the one answer. Okay? So questions on using the quadratic formula, identifying the discriminant, and determining the type of roots there are.